In this lesson, we're going to be talking about dilations. This is our last type of transformation that we are going to talk about. And I want you to think about the word dilation. I think one thing people think about when they hear the word dilation is they think about somebody's pupil in their eye. And we know that the pupils in our eye, they dilate, which means that they get bigger or they get smaller. A dilation just means that we are enlarging or reducing something. Okay, so it can be either way, and we're going to talk about how to recognize that. It says to dilate a figure on the coordinate plane, you multiply the x and y values of each ordered pair by the given scale factor. And we're going to talk about scale factor. Describe what should happen if the scale factor is greater than 1. That's really, really important. If we have a scale factor that is greater than 1, then this is an enlargement of our figure. Okay, we're multiplying it by something greater than 1. If we multiply by 2 or 3 or 4, our numbers are going to get bigger. If the scale factor is less than 1, and just know the scale factor will never be negative, but if the scale factor is less than 1, then this is a reduction. We are reducing it. If I multiply by 1/2, we are halving a number, so the numbers are going to get smaller, right? So hopefully that kind of makes sense. When a dilation has occurred on the coordinate plane, you can find the scale factor by choosing corresponding sides or vertices and setting up a ratio. And so there's two ways to think about this. The scale factor is always the new figure over the original figure. I always say, wouldn't you rather have a new phone over an old phone? So new over the original, or we could also think of it as the image, because we know that's the new figure, over the pre-image. And so that's really important because that changes the way your ratio looks. Okay, so looking at this example, it says dilate the rectangular figure, or rectangle shown by a scale factor of 1/3. Record the coordinates in the table. Now, I want us to think, if we have a scale factor of 1/3, that is less than 1, right? So that means this is a reduction. I just want us to take note of that this is a reduction because our scale factor is 1/3. Now, if you'd like to pause the video and go ahead and write down your coordinates for A, B, C, and D, then do that. I'm going to write them real quickly here. We have -6, +3. We have 6, +3. 6, -3. And -6, -3. Okay? Now, we said in order to dilate the figure, we are going to multiply both the x and the y value by our scale factor. Now, nobody panic. I know this is a fraction, but you have a calculator to help you with this. You're going to do -6 times 1/3. Now, if you're doing it by hand, let's look at what that would look like. That would be -6/3, which is -2. Okay? And then if I do 3 times 1/3, that's just 3/3, which is 1. Okay, B prime. I mean, this is going to be easy because their numbers are basically all the same except for the negatives. So here, this would be +2, 1. C prime is going to be +2, -1. And D prime is going to be -2, -1. Okay? It says, how can we represent the dilation algebraically? So this is what our dilation rules are going to look like. You know, we start out with x comma y, we draw our arrow. Now think about, what did we do to each point to get the new point? What did we do? We multiplied the x and the y by 1/3. So all we have to do is show multiplying the x by 1/3 and multiplying the y by 1/3. And it always has to be both the x and the y being multiplied by the scale factor. Okay, so it says compare the ratios of corresponding sides. What do you notice? Okay, so I'm going to need to draw, -2, 1, that is A prime. B prime is 2, 1. C prime is 2, -1, and then this is D prime. Okay? So it says compare the corresponding sides. So corresponding means they're in the same position, the same place in the rectangle. So let me kind of show you. So we have AD and then A prime, D prime. Those are corresponding sides. How long is this side? 1, 2, 3, 4, 5, 6. That's 6 units. A prime, D prime is only 2 units. Okay? So remember, we want to do the new over the old or original. So our new figure is 2. Our old figure is 6. What does 2, 6 reduce to? 1/3. Ooh, look, that's our scale factor. Okay, let's look at side AB. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. And A prime, B prime, 1, 2, 3, 4. This is 4 units. Those are corresponding sides. So again, the new 4 over the old 12. Up, look, that is also 1/3. So that shows you the scale factor. That's a way that we could determine the scale factor. Okay, question 3 says, did the dilation change or preserve the orientation of the figure and the orientation of the vertices? So my question is, did we turn this at all? Did a dilation turn? And the answer is no. All it did is got bigger or smaller. So the sides are still in the same place. The vertices are still in the same place. So the answer is yes. It does preserve orientation. Notice it did not preserve congruency because we got smaller in this case. Okay, so let's look at the next one. Dilate the figure by a scale factor of 2. Scale factor of 2. So I ask you, is this an enlargement or is this a reduction if its scale factor is 2? Well, I hope that you said to yourself that this was an enlargement, because if it's a scale factor of 2, that means we're multiplying the numbers by 2 and we're getting bigger. So let's see, E, F, G, H. Let's write down our coordinates. We've got -4, 2. We've got 4, 2. We've got 3, -1. And we've got -3, -1. Okay? Now this one's a lot easier. If our scale factor is 2, all I have to do is multiply each of these numbers by 2 to get my new point. So E prime would be -8, +4. Okay, F prime, again, we're just multiplying by 2. So 8, 4. Okay, G, multiplying each by 2. Look how easy that is. Dilations are easy. 6, -2. And so then H, -3 times 2, -1 times 2. H prime would be -6, -2. Okay. How do we write the rule? X comma Y, draw an arrow, and then we have to show that both the X and the Y are getting multiplied by 2. So as simple as that. I would like you to do number 5 on your own, and I will have the answer to that in a separate video. Okay, I want us to skip to number 6, though, together. It says, find the scale factor that was used in the dilation. Okay, so we can do this a couple of different ways. If we can find some corresponding sides that are straight, that are horizontal or vertical, then we can do the scale factor with our sides. We can also use our points, okay? So I think for number 6, we're going to find the scale factor with the sides, and then number 7, we'll look at how we can do it with our points. Now, the first thing we want to make sure we know is which one is our pre-image. So here is our pre-image, LMN. Remember, the one that doesn't have the prime markings. And let's look at corresponding sides LM and L prime, M prime. So this is 1, 2, 3, 4 units. This one, L prime, is 1, 2, 3, 4, 5 units. Okay? Remember, we want to do the new over the old. So the new image was the L prime, so 5 over 4. 5/4 is our scale factor. Let's double check it with line MN and M prime, N prime. This is 1, 2, 3, 4. This is 1, 2, 3, 4, 5. So it's still 5 over 4. That is our scale factor. Notice our figure got bigger. This is a scale factor greater than 1. So that's another way that we know we did this correctly. So the scale factor is 5/4. Now I do want to point out that you cannot use this diagonal line because we can't count that on the coordinate plane. So we can only use the 2 sides that we talked about. Okay? Okay, let's look at number 7. Let's use our points this time. And so again, we want to know which one is our pre-image. So here is our pre-image. So now let's take corresponding points, points that are in the same position. So I have Q, point Q. I'm going to pick that one, which is 3, 6. Okay, and then I have Q prime. That would be its corresponding point. So Q prime is 1, 2. Okay, remember the prime is our new one. This is our new point. This is our original or old point. And so all we have to do is take the x values or take the y values and write them as a fraction. So let's just start with the x's. The x in the new one is 1. The x in the old one is 3. So I think the scale factor is 1/3. Let's test it with our y's. My y value in the new is 2. My y value in the old is 6. Does 2, 6 reduce to 1/3? It absolutely does. And so our scale factor is 1/3. Now we could test that. We could do P and P prime. We could do R and R prime. But they all should result in a scale factor of 1/3. Notice our figure got smaller. So we have a scale factor less than 1. So that's a way to check yourself. Okay. Okay, so I want you to see now, same thing, I want you to see if you can do 8, 9, and 10 on your own. And so in the next video, you're going to check your answers.